How much pollution should society allow? The key to finding the efficient quantity lies in balancing the costs and benefits of reducing pollution. The supply curve reflects the marginal cost of pollution abatement, what it costs businesses to reduce emissions. The demand curve represents the marginal benefit of pollution abatement, the societal gains from cleaner air or water. In this video, we'll explore how these curves intersect to determine the optimal level of pollution abatement, maximizing net benefits. In this video, I'll show you how economists calculate the efficient amount of pollution and how we determine that. Right? So the idea is we want to compare the marginal benefit of pollution reduction to the marginal cost of pollution reduction. The marginal cost of pollution reduction is going to come from the individual firms, saying how costly is it to reduce your pollution by a given ton, right? So how much does it cost Miami University to reduce its pollution by a ton? How much does it cost American Airlines to reduce its pollution by a ton? The benefit side of pollution reduction is going to be from, like, let's just say the health benefits of not having dirty air, right? And so we can say, like, we're going to save X amount of lives from people with cleaner, once we have cleaner air, we can put a dollar amount on those cleaner lives, and that's where that marginal benefit dollar calculation is going to come from, right? So to find the efficient amount of pollution, we want to set pollution reduction where marginal benefit of pollution reduction equals marginal cost of pollution reduction. So calculating or figuring out where that marginal benefit side comes from is a little bit beyond the scope of this course, but we can get through, like, how do we think about the marginal cost of reducing pollution relatively quickly. Okay, so what we have here is a table. We have three different firms: firm A, firm B, and firm C. And so the current pollution level is that all of them are polluting 30,000 tons. Okay. The first column tells you how much does it cost for that first 10,000 tons of pollution reduction for firm A, firm B, and firm C. So for firm C, it only costs them $10,000 per ton to reduce that pollution, first 10,000. For firm B to reduce by that first 10,000, it's cost them $30 per ton. And for firm A, it costs $50 per ton. Okay, so we have low price, medium price, high price to do some pollution reduction. Now, the other columns are reduced the second 10,000 and the third 10,000, right? So for firm C, that first 10,000 for them is $10 per ton to reduce, then it's $20 per ton to reduce, then it's $40 per ton to reduce that third. And so once they get to this column here, there's no pollution. They start with 30,000. If they reduce the first, the second, and the third 10,000, over here, there's zero pollution. But notice that we have increasing marginal costs within a firm, right? 10, 20, 40. Firm B, 30, 35, 45, increasing marginal costs of reducing pollution. And then for firm A, 50, 100, and 200 to reduce that pollution. Right, so the idea of increasing marginal costs of reducing pollution within a firm is that, well, you're going to start with the easy, cheap stuff first, then you go to the medium, costly things. Then in that final stuff, these are going to be the hardest things. Those are the ones you want to leave till last, and those are going to be the most expensive. So we're going to take this table and construct a marginal cost of pollution reduction curve to use it in this calculation up here. All right, so we want to start with the lowest marginal cost pollution reduction, and then start adding in the higher cost pollution reduction. So on this table, we want to find the cell that has the lowest dollar amount per ton. And so that's going to be this first cell for firm C. That $10 there is the cheapest, and so we're going to start with that one. The next cheapest is going to be $20, and so then we'll do that cell there. The next cheapest will be $30, and we'll do that cell there. Oops. And so on. So now we're going to go for firm B. The fourth cell will be that one, $35. We'll jump back to firm C to do that $40 per ton one, cell 5. Then we'll jump back to firm B and do the sixth. Now we can jump to firm A, and we're up to $50 per ton, $100 per ton, $200 per ton. Okay, so those numbers there tell us the order of who's going to do the reducing. We'll do 10,000 here, 10,000 here, 10,000 here, 10,000 here, 10,000 there, and so on in that order of doing our pollution reduction from the cheapest to the most expensive. So on this graph, we have prices to reduce that pollution by a ton over on this axis here. So this is dollars per ton. And then we have the quantity of pollution reduction over here. This is 10,000s of tons. So 10,000, 20,000, 30,000, 40,000, so on. So remember, we're going to start with 1, then go to 2, then go to 3, 4, 5. So the first one is going to be that firm C, that first 10,000, and that's going to be, put a dot there for $10. Then the second one is going to be, again, firm C, and that's going to be at a price of $20. And so these are going to be firm C, that's doing that reduction. Now we're going to jump up to firm B. They're going to do their first 10,000 of reduction at a price of $30,000. Then we'll do right here we'll do this one here, $35 per ton, firm B for that 40,000th. Oops, $35. So that's firm B. Now we'll jump back down to firm C, do the last 30,000 for them. That's $40. Then back up to firm B for cell 6, and that's $45, firm B. Right, now we can jump up to firm A. This is a really costly firm. So you think American Airlines, where it's really, really costly to reduce pollution. And so we'll have $50, $100, $200, for firm A for those next ones. So we got $50, $100 at 8, and $200 way up here for firm A. Great. So the idea here is these will be our marginal costs as we go in that order. And so we can connect this line here. We trace out the actual reduction in pollution to each of these firms. It's going C, C, B, B, C, B, A on those firms and those cells. Okay. We've now created our marginal cost of pollution reduction to do our cost benefit calculations. Great. Now we'd have a marginal benefit of reducing pollution. Let's say that curve was going to cut through right there. Our marginal benefit of pollution reduction, like so. All right, so we only want to reduce that pollution as long as the benefit of reducing the pollution is greater than the cost of reducing that pollution. So keep on going as long as that marginal benefit is greater than the marginal cost. Stop where they're equal. Don't do these over here. These are really costly and you don't gain much from them. So don't do these. This is bad. We should actually pollute. This is what this graph is telling you. Pollution should not be zero pollution. There's going to be some positive amount of pollution that the economy should do to make it efficient. All right, so where these cross, we'll put a dot right there. That's at a quantity of 50,000. And so that will be our efficient quantity of pollution, like so. Okay. Right, so what this graph is telling you, the economics say we should have 50,000 ton reduction in pollution. That's the efficient amount. So how much pollution should there be? Well, in this graph, let's just say this is in this table, this is all the pollution there is. So that's 90,000 total. And so really we're starting from here, from that amount of pollution, 90,000. So actual pollution is going to go from 90,000, right, to there. And so we're going to have, if we reduce 90,000 by that 50,000 of that reduction, we're left with that amount of pollution. Okay, so that's 4 units, 1, 2, 3, 4. And so we would have 40,000 tons of pollution left. That's the efficient amount of pollution. Okay. Okay. So who's doing actually, let's just do taxes. What should be the proper tax to get us to the right amount of pollution, efficient amount of pollution? So if you're going to set a tax, you should set it to go right through that dot there, that efficient quantity. So you can take your 50,000 pollution reduction up to that equilibrium, come on over here to that 40. So you should set a tax if you're going to do this. Set tax equal to $40. That's the marginal cost of pollution reduction at that efficient quantity. Okay, so if you set a tax equal to $40, who's going to do the reduction? It's going to be these firms here, where it's cheaper to do the reduction. Here's your marginal cost of actually doing the reduction, rather than paying a tax of $40. You'd rather spend less to actually reduce the pollution. Over here, these are going to be our really costly firms to reduce the pollution. They don't want to do it. They'd rather pay the $40 tax and keep on polluting. That's better for their profits, right? And that's exactly what the economy wants firms to do. So we don't want these firms to reduce their pollution. We want these firms to keep polluting because the cost of reducing that pollution is greater than the benefits to society. So we want American Airlines to keep polluting. We want firms like Walmart, Miami University. It's really cheap for us to reduce our pollution. If we're going to do it, we want those firms to do the pollution reduction. All right, last one. If we were going to set cap and trade, we should set our quantity equal to our efficient quantity of pollution. And so this should be the permits. Set permits equal to 4 tons. I should say 40,000 tons, right? So our equilibrium amount of, or efficient amount of pollution is 40,000 tons. So set your permits equal to 40,000 tons. And that will get you to that efficient amount of pollution.